Thank you very much. Okay, so apologies for also doing my presentation in English. Ich kann auf Deutsch, aber es ist für mich ein bisschen einfacher auf English. So we're going to be talking about how companies can use identity resolution to create this so-called single customer view. And in particular, we're going to be talking about last-mile logistics here. So the problem which is particularly acute for last-mile logistics companies is that they will be working with hundreds or thousands of different retailers, and every single retailer is, of course, sending them customer data. The customer name, the email address, and of course, most importantly, the actual delivery address. But each retailer is sending that customer data in a different format, and that can create quite significant problems. So here's real examples of data from the UK of how different shops send the customer data. You can see, for example, that the shops are doing seemingly fairly random things. The TikTok shop is splitting the address line across 2 fields if the first address line is too long. John Lewis is replacing the first name always with an initial. AliExpress will strip out your first name, so you've only got a surname there. Email addresses are always quite difficult because many of the marketplaces will strip out the email address and use one of their generated email addresses instead. And this causes a number of problems. It means that for the last-mile logistics company, they are unable to create this single customer view. They cannot say that these 10 different customer records actually belong to the same individual person. And practically for the logistics company, this means that they can't share customer preferences across different retailers. For customer service, it creates a problem. When someone phones up, it makes it difficult for them to automatically identify the customer in their system. They can't know if the customer has got multiple deliveries coming to them because they will only be able to identify the deliveries from the one retailer. It can cause problems with just generating the contact details in general. It means fraud can go unnoticed because you might not be realizing that all these deliveries that are being sent to the same location are apparently for the same person. And it causes problems in the data analytics departments because they're unable to attribute deliveries to individuals within locations. In the data science world, this is what you would call an identity resolution problem. Identity resolution, it sounds fancy, but it's simply put the process of identifying and linking different representations of the same real-world identity across various different data sources or within a single database. Put most simply, you can think of it as deduplication within a CRM system. Almost everybody's CRM system will have a large number of duplicates within them. More complicated cases are when you're trying to unify data across different data silos. Those could be internal data silos, customer CRM system, a marketing system, transaction database. The typical company will have 20 to 30 different systems which contain customer data. And it can be very challenging to actually unify that data across those systems. So this is what we call identity resolution. And this is what my company, TiloRes, solves. We were born in a German consumer credit bureau. And this is a problem which is particularly apparent in credit bureaus. You can imagine they are sourcing data from many different sources, and we have to be able to provide that data to customers, be that banks or debt collection companies, to say this is all the data about an individual person. So we developed this technology inside a credit bureau and then spun it out into a separate company to sell the technology directly to customers for various use cases. So there's 3 main things that we're doing in our system which help resolve these identities together. The first is data transformation and normalization. So when you're sourcing data from multiple different systems, they will all have different ways of describing the data. Put most simply, you can think of it as things like how you name the database fields. You might call it first name here, F name here. You might have last name, surname, L name. All these different database fields need to be normalized so you can actually compare fields across databases. As I showed in the earlier slide, the actual data that comes from different systems can be exceptionally messy. Easy examples are things like people using email addresses and adding a plus sign into them to make different email addresses, people putting in phone numbers in different formats, spaces, special characters, punctuation. All these things are what we often see in enterprise data that needs to be cleaned to make it easier to link the data together. The actual linking of the system is where the magic happens. We're using various algorithms to link and deduplicate the customer data with extremely high precision. And then what we end up with is what's called an identity graph. And it's basically a holistic way of looking at all the data about an individual person in a way which is the most logical representation of the data. And I'll show you what that means in a second. Now, you might be listening to this thinking, OK, this must be some kind of AI application. We actually don't, as standard, use artificial intelligence in the way we're matching the data together. We're a rules-based system. We're using various algorithms which are used in the data science world to look for similarities. They're looking for what is the difference between two strings of text. They're looking for are two texts phonetically similar, for example. There's about 20 different algorithms that we use in various combinations to be able to say, OK, if this person has a similar first name and a similar last name, and the address is the same, then we can say those two records belong together. Perhaps the last name is the same and the email address, once normalized, is the same, then we can join those two together. Maybe we're using a nickname library, so we can tell that Bob is actually linked to Robert, even though the two don't actually have much in common with each other. Again, we use those sorts of libraries to combine the data together with this rules-based system. The reason we use rules rather than artificial intelligence is that we are working in lots of different areas, and we're very often working in regulated industries. We're working with financial services companies for compliance and KYC, know your customer. We're working in anti-money laundering. We're working in fraud prevention. And the benefit of being rules-based is that it's highly explainable. When I link two records of data together, I can say the reason we link these together is because the threshold for these algorithms over these data attributes was matched. It's repeatable. If you put the data in several times, you will always get the same result, whereas with artificial intelligence, it's a bit more of a black box. So this is what we prefer and our customers prefer. So I talked about the so-called identity graph, and this is visually speaking what this actually means. So you can see on the left, you might have a number of different delivery records that are generated by Amazon, and you're able to link those to the delivery records from eBay. On the other side, you can see that the data from Otto is linked via another retailer to the data from Zalando. Now, the data from Amazon and the data from Zalando is not directly linked to each other, but through this graph representation of the data, you can see you could connect the data from Amazon to Zalando via these intermediaries. And this is actually a reasonably real-world representation of how the data actually visually looks when you're using it in an identity resolution system. We are an identity resolution as a service. We run on AWS. We're a partner of AWS. And we can either run in your own infrastructure. Many of our customers prefer that so that the customer data is never leaving their own environments. Or we can be managing the data for you. In our user interface, this is how the graphical representation of the data looks. It's not how you're actually using the data, because obviously that's not actually useful, just a visual representation. But this is the sort of thing that you're actually getting out of the data in the end. So the so-called single customer view, you might also consider it a customer 360 or a golden customer record. But you're able to say, OK, from the 1 to 1,000 records that are in this so-called identity graph. Here's the probable first name for this person. Here's the probable surname. Here's their most recent contact details. You might have a history of their contact details from when they've moved house. You might also have their different delivery details if they've got business delivery details and home delivery details. You saw before that we had, for example, the email address being masked. So even if the email address is masked, you're still able to find all the other email addresses that can be attributed to this identity. So then you get the probable real email address. You get the most likely phone number for this person. And of course, now, because all the data is consolidated from these different sources, you now know how many packages that individual person is actually receiving. You'll be able to find out how many packages they have currently in delivery. You'll be able to see their most common delivery preferences. And from the support point of view, you'll actually be able to get this holistic view of do they have open support queries with this at the moment. So we did this for a very large national last-mile logistics company that had tried this many times. They had made, they tell us, 5 attempts to solve this single customer view problem, usually with consultancies spending pretty significant sums of money trying to solve this. Unfortunately, this is a sort of problem that, for many consultancies, looks like a relatively easy thing to solve. It's the sort of thing that a data scientist on their laptop can solve with a very small data set, but once you try and expand this to tens of millions of data records, it's extremely difficult to actually make it reliably work. So we worked with this company, took their 150 million customer records. There's, of course, not 150 million individuals in any European country. And we resolved that data down to 38.1 million unified profiles, or 38 million single customer views. What was especially amazing about this is it was a very quick process. The entire POC for us only took 3 weeks. And that was the process of refining these rules, testing with smaller data sets, and then building up where they could run this in their own infrastructure, put the entire 150 million records in, and get these 38 million single customer views. This is a very fast system, so we can be ingesting into our system tens of thousands of records a second in parallel without any performance limitations. And when you're searching the data, you're going to be getting any volume of results back in about 100 milliseconds. That's thanks to the infrastructure that we have through our partnership with AWS. So for this last-mile logistics company, this has turned a significant data problem, which they had tried to solve many times, into a competitive advantage. So for them, it's improving their delivery operations, leading to reductions in failed deliveries. For them, it's an important tool for customer service where they can resolve queries with the first contact. It significantly enhances the potential for fraud prevention because they can detect networks of people that are trying to pretend to be separate but are actually related to each other. Provides cross-selling opportunities for them with individual end customers. And last point, although we're not especially AI-based, we make a very good basis of data for AI applications. So we offer something that we call Identity RAG, which is where companies can build AI applications on top of our data. That works extremely well, extremely nicely, especially in this case as well. So happy to have a discussion about how we did this and talk to you about whether we can help you improve your customer data. Again, to emphasize, this is something where we can prove the value in a manner of weeks rather than months or years. Happy to take any questions. I'm happy that my counters here have still only got 15 minutes to go, but I'm pretty sure I only had a 50-minute talk booked. So we could do 50 minutes of discussion if you like.
So I'm not the fastest person, but If there are any questions, you can also use, ihr könnt außerdem den QR-Code ganz einfach nutzen und dort nochmal die Fragen, die ihr habt, eintippen. Die befinden sich auf der Rückseite der Stühle, kann auf Deutsch sein, kann auf Englisch sein. Ich denke, das kriegen wir beides hin. Und natürlich auch gerne mit Handzeichen, wenn ihr eine Frage habt, auch das ist möglich. Ich schaue mal gerade, erstmal analog sehe ich keine, aber ich gucke jetzt mal in unser Slido-Tool und eine Frage haben wir jetzt hier, die ich erstmal, Steven, auf Deutsch so verlese. Was ist mit Datenschutz und Missbrauch der aggregierten Daten, wurde gefragt.
Okay, so Datenschutz, I mean, we come from a German consumer credit bureau, so you cannot really get more strict about data protection than a German credit bureau. So we're just a data processor. At the end of the day, you have to have the right to A, have the data, and B, connect the data together. We have a lot of things built into TiloRes that are built for data compliance, such as you can say data from a particular source has to be deleted automatically at a particular time. So every day, data that is exactly 1 year old from source A or 1 month old from source B will be deleted from the system. This sounds simple. We're all used to deleting data from our computers and phones, but it actually is quite complicated because those identity graphs need to kind of self-reorganize. If you have the logical piece of data in the middle of one of those graphs that's connecting two other bits of data together, and you delete the middle one, the whole thing has to reorganize. And what you will actually have is the entity splitting. The opposite can happen as well. You can have one piece of data come in from another source, which connects two graphs together. So that's the sort of thing that, that we can take into account.
If there are later any questions, where can we find you today and tomorrow?
Well, I am standing at the startup booth directly opposite us, so you're welcome to come visit me there. Email me, steven@tilores.io, find me on LinkedIn und wir können zusammen mein Deutsch üben, wenn Sie Bock haben.
Dann können wir jetzt an der Stelle erstmal sagen, vielen, vielen Dank für deinen Input. Dankeschön.
Danke.